Okay, so I'm going to start recording now. Just so you guys can, I'll post this recording up on YouTube so you guys can see how the course went. So yeah, homework 1.1 and 1.2 due tonight. You want to be trying to finish up the first week of fluency journal activities as well. So if you hopefully you've seen the fluency journal file, the mathematics indicator file, which is the flashcards type test for addition and multiplication. Hopefully you've tried those. And as I said before, we have the first 5 or 10 minutes for fluency. We'll have you guys try fluency activities, but then we can also go over some sticky points and breakthroughs. So we can discuss some of those fluency ideas. And we'll see what those are next week. And then also for Monday, we need you to make some cutouts of base 10 blocks. Now we're going to go simple on these, and so what I've done is you can go on the internet and find some sample base 10 blocks sets. You can just come out. But what I did here is I drew out 10 squares. Okay, those will represent what we call flats. There's 10 sticks. Those are called rods. And then I did 10 little squares. They're called little cubes. Okay, so you can look for base 10 blocks. For next Monday's lesson, just cut out 10 of each of the types. And they have a big cube that we don't need to worry about for next week's class. So please be sure to just have cutouts ready when you come on Monday. 10 squares, 10 sticks, and then 10 little squares. Any questions so far?
I have a question. So I think I'm missing something here. I have the 10 squares, the 10 sticks, and 10 cubes.
And 10 like little squares. We'll try and put those up here again. So you have 10 regular size squares, 10 sticks here, and then 10 little squares. Okay, these will represent like ones and tens and hundreds. Okay, so you have one little unit cube here. You'll have 10, those are going to be 10 little cubes stacked there. And there's going to be 100 of them, so 10 sets of 10 there. Right, so that's how that's working.
Okay, thank you.
For our next class. All right, so let's go over some homework questions. Who would like to have a homework question?
I do. My question was on number 13 on 1.2.
Okay. 13 on 1.2.
I just don't remember doing anything similar to that.
Oh, we don't. No, we didn't do that one. I have a multi-user whiteboard.
I also looked for that problem in the textbook, the elementary mathematics, and didn't find an example. The closest it was Roman numerals.
For 13?
Yeah.
Yeah, no, we didn't. This is a problem that probably Dr. Walters made up. It's not on anything that is in the book.
Oh, okay. Just wanted to make sure.
Yeah. So, all right. So in the problem, they give a number line. And I'm trying to see if I can pull that up here. Give you kind of the structure. Yeah, I don't know how to. All right. Well, anyway, I'll go ahead and just draw it on paper and show it to you guys. So that they have a number line here. And when you have order on a number line, you have a starting point, and then everything that goes to the right on the number line is larger than the numbers that are on the left. Okay. So what they have here is on the number line, they have 1, 2. It's like they have these little symbols like a caret, pound sign, at sign, mu, L, and W. Okay, and so what they have is those are like in order. So I put like 1, 2, 3, 4, 5, 6 here. Okay, and so what you have to do is you have to like look at the places on the description of the numbers. So for example, we have our red, green, blue, yellow places. Okay, and A is going to has the level of at sign in the green, level of L in blue, and W in yellow. Okay. All right, that's okay. Okay, so I was drawing in pen. You should never do math in pen, so I messed up a lot. Let's redraw this here for you. Okay. And so they only have the green and the blue and the yellow on their chart. Okay, so there's nothing in the red. Okay, so number A has at sign in green, L, and W. Let's try this here. Okay, so I drew the number line again up here. I put some actual numbers down there to show order. Okay, so the one to the most left is 1, and then 2 and 3. As you go towards the right, they get bigger. Now the first number was A, and it has at in the green place, L in the B place, blue place, and then W in the Y, yellow place. Okay, so this is the one that has the least amount of value. This one is the base number times that. So like if this is like the ones place, that's like the tens place, and that's like the hundreds place if we're using base 10. Okay, and so with this analogy, when you compare numbers, every number that's given A, B, X, H has only to like the hundreds place or the base cubed. So when you compare numbers, you start with the first base, the greatest number, and which is the one that's to the most to the left. And you compare all three of those, or all of those first between everybody. Now, everybody has only 3 places in their numbers. Okay, so we can go ahead and compare them. So A, B, X, and H are our numbers. And in the first place, we have A has the at sign, B has a caret, X and H both have the mu, which is a Greek letter. Okay. And so when we compare the numbers, this is like the hundreds place, and that's all for base 10, and that's all we need to compare to start. Now, which one has the we're ordering from least to greatest, and so which one has the least value? Okay, so we have the @ sign for A is there, the caret for B is here, and then we have mu for the others. So the one that has the least one is B, because it starts with, in the hundreds place, I'm going to use that for just an example. In the highest place value, it has a caret, which is the lowest character in our order. Okay. So B is going to be the least, the number that is the least. This is your order. B is the first one. It doesn't matter what else is in B because it has the smallest value in the first place. Okay, we were comparing all the same places. So if you're comparing three numbers that are to the hundreds place, you have to compare what they have in the hundreds first. Okay. Now, since A has the @ sign, which is actually the couple numbers ahead of the caret, then that will be the next least greatest. Okay, the next least greatest is going to be A because it has an @ sign in the hundreds place. Now, X and H both have mu in the hundreds place. Okay, and mu is the same. So when we have the same value in the hundreds place, we have to look at the next place down to see which one is bigger, and that's in the blue. Okay, so in the blue, we have for X and H, we have the pound sign or hashtag and then A, the @ sign. So we're comparing these two numbers here. They have the same value in this place, but not in this one. So looking at our number line, which one is least? Okay? So we're going from least to greatest. And when we compare here, we have the @ sign, the pound sign first, and then or hashtag, and then the @ sign. So hashtag is lower than the @ sign. So the next least number is X. And then it's H. And so by that reasoning, we've put all of the letters in order. So that's what they want you to know, is to explain how you decided that. So how was that? Any questions?
So when the question is like, put them from least to greatest, so that makes sense how you got B, A, X, H. But then when it says explain how you decided that, do we just say because from B to H, B contained the least on the timeline?
Yeah, on the number line, B has the smallest character in the highest place value. Then A has the next smallest, or the next one up from that. And then X and H, you'll have to explain a little bit more by saying they have the same value in the highest place value, but in the next highest, they have X has the lower value than H. So something like that is a more concise answer.
And then I also didn't understand 14 or 15, if you can kind of help with those.
14.
Professor, sorry.
Oh, go ahead. Someone have a comment?
For 13, I already submitted it, but I put BAHX. Should I just resubmit a new one correcting that? Because I had H and X swapped.
Yeah, so what you can do is that you can, when you have like most of everything the same for your file, and you can, when you resubmit, you put all the things there again and then press submit. It will overwrite whatever you have submitted there. And I won't look
perfect.
until like tomorrow or Monday.
Okay.
And you guys can feel free to make adjustments and then it'll rewrite over.
And for the deciding factor, I decided based off of the smallest value in the chipboard because I was comparing that to the graph. Is that okay? Or should I rewrite that as well?
Oh, say that one again.
For the explanation, I put that I decided it based off of the smallest value in the chipboard because I organized it from ones, tenths, and hundreds.
Yeah, so you have to like take the smallest hundreds place and then order that way. Yeah.
Yeah. So is that acceptable, or should I rewrite it as well when I resubmit?
Yeah. If you feel you want to rewrite something, that's fine.
Okay, sounds good. Thank you.
Mm-hmm. Yeah, so the idea is just going from least to greatest.
So I think I could explain 14 and 15.
Well, you have to, with 14 and 15, you just have to list the numbers. Okay, so it's like listing the first 50 numbers in base 4, right? That's 14.
Mm-hmm.
So here's what we got for the first 50 numbers. I did them all out for grading purposes. And what you do is you have to start counting. Okay. In base 4, you're using base 4. When you get to 4 objects in the ones place, then you will be able to group those together, and you group those together, and then you write a one group of 4 in the like the tens place, but it's the base value. And when you start counting, I started from 0. You can start from 1 if you want. That's okay. So people interpret that differently, and I'll make allowance for sure. So we have 1, 2, 3, but we can't have 4 in our ones place, in our leftovers. So we have to bundle all those together, those 4 objects, and put them into 1 in the next place over. So with base 10, that's going to be the 10th place, which is what you're used to. But with base 4, that's going to be the 4th place, whatever the name the base is. You have one group of 4 here. And that's the idea for what 10 means. Okay? This symbol for this number, for how many there are, means 0 leftovers and 1 group of how many there are the base of. Okay, so we need to start seeing this differently for place values. You'll be teaching that to your students. They will not know what 10 means. And it's important. They will know that it's a number, and they will know that it's 10 objects, but it actually has more to it embedded in it than what we think initially, what they will come initially to school with when you teach lower elementary. It's important to know that 10 is no leftovers, 1 group of 10, because we're going to use that when we get to addition and multiplication. So in base 4, we're going to start counting, and after that we have the next number is adding another dot into the ones column, and you have 11, or I should say 1, 1 base 4, 1, 2 base 4, 1, 3 base 4. Now 3 cannot be, after that you have 4 in the ones column, but you can't have 4. You have to bundle those together and put another number in the 4's place. So you have 2 groups of 4, no leftovers. Okay, that's 2, 0 base 4. And you continue in that fashion until you get to like 33, or 3, 3 base 4. If you put 1 more in this one, it'll become 34, but you can't have 4 in this one. So you bundle that one you put into the 4's place. Can't have 4 there either. So that means you bundle those 4 and put it into the next place over, which is the 16's place. You have 4 groups of 4 there. Now, this type of thinking is explained in my video, so I'm hoping you guys have seen them all. If not, please review them again to help count. So those are how you count in base 4. Now, in problem number, or is there any questions about counting in base 4 for 14?
No.
Okay, in number 15, you're counting base 2. Okay, and so base 2 goes 1, and you increase the ones place by another one, which makes it 2 in the ones place. But you can't have 2 in base 2. You have to bundle them together and put them into the next place over, so that you have 10 next, or 1, 0 base 2. Then you add 1, 1. And then you put another 1 in the ones place, but you can't have 2 in that one. So you bundle that and put it 2 into the next place here, the 2's place. But you can't have 2 there either. So you bundle that together and put it in the 4's place, which is the next one over here. So that's why it's 1, 0, 0 next. Okay. And this is called binary, base 2, which is called binary numbers. And this is something that computers used when they were first invented. And they still use them now, but they're not as apparent. So that's another famous number system. And then base to count. So we do have to kind of move on a little bit. If you have any other homework questions, you can feel free to send me an email, or we can do a Google Hangout chat if you need to do a video chat to ask them and get an explanation. So please keep in communication with me as we go through the course, so that you can see how get the best help you need. Okay. For our lesson today, we're going to do what you need to know for homework 1.3. So it's kind of I'm going to call this section 1.3. Okay. And what 1.3 starts out with, there's 3 concepts that we learn. And if you do the reading, the homework starts out with the reading from the book. Now the book introduces a lot of addition topics, place value topics right away, and kind of I don't know if it's how organized it is, but what I think that the homework does well on is it separates it out into basic concepts and skills, and it covers it better. So we can read the section in the text for sure, but you want to know that they introduce a lot right away, and that will take a couple of days, class days, for us to work on them. Okay. So the first concept is we're going to review the names of the places in base 10 numbers. Okay, base 10 numbers are called decimal numbers, okay, because decimal means 10, like deci is Latin for 10. So we have names of places in base 10 numbers. Those are called decimal numbers. Now, if you have a number with a decimal point in it that has parts, that's called a decimal. But just like base 2 is called binary numbers, which means 2, decimal means 10, so deci. So you've seen that before. Those are called. Well, how far can we go in our decimals? So I'm going to draw a little chart here. Okay. In this chart, I've drawn a decimal point, okay, right here. That means that this is going to be the ones place. The ones place, okay. The ones place is the first place that has a decimal point after it, okay. And there are many places that you can go this way, to the left. Okay? We're going to try and name those, and we'll write them down. So after the ones place, you have the tens and the hundreds. Okay, thousands. Okay, 10,000s. Okay, and so I'm going to show you what I've got so far. And so you guys, if you take some notes on this. Okay. And so you want to do something similar in your notebook. You can turn it to the side if you have lined notebook paper or what. You want to see how far you can go. What are the names of all these places? Okay. So everybody got the idea? Okay, so I'm going to give you a minute or two to just to fill out as many as you can. Keep going as high as you can go. And we'll see what you guys know. So go ahead and do that, and I'm going to have some people share out with their, hopefully, I don't know how to do this on this program. Hopefully you guys can see other people, everybody else.
At the bottom of your screen, if you click the camera, it will let you screen share. Like if somebody wants to share.
Yeah, are you, everybody can see me, right? Can people see Ariana and Sydney? Is that how you say your name, Ariana? Okay, I didn't hear that actually. Can you try again? Is your microphone hooked up? Oh. Okay, yeah, so I can't hear it.
I can hear, I can only see.
Yeah. Okay, anyway, go ahead and keep working on this and see how far you can get. And I'll start writing some down here. And you want to try and practice words, okay? So one thing that you do in elementary school is you write words names for each of the places for the numbers. That's what that's like our concept number 2. Number 3 actually, words. And what we have here are actually, when you say ones, tens, hundreds, those are adjectives to describe the place that you're at. Okay? So it's not like they have any possession or anything, but it's an adjective. Okay. We have 15 people here, but I only have like 3 cameras activated. So let me know if you guys have camera issues. We have, anybody have a way they can show what they've got written down so far about these places? Someone do that? So can everybody see Melissa's? Oh, Lindsay, you good? All right, so you guys are like fast.
Can you guys see?
What's the highest place value you guys thought of without looking anything up? So people shout out. You can see
Quadrillion.
Yeah, a quadrillion.
Yeah.
Awesome.
Is anybody else's screen on? Because I can't see anyone else but you, Professor.
Okay. I have about, on mine, I have 1, 2, 3, 4, 5, 6 people on.
I can see the professor, but that's it.
Oh,
Yeah.
maybe to us it's only yours and ours, and you could see all of them.
I
Yeah,
think
because I
that's
can't
true.
see anybody either.
That might be one good thing, and I'm kind of leaning towards going back to Zoom. Okay, good. Thanks, Sydney. What we have is, I'm going to show, I went up to the quadrillions place myself. I'm going to kind of zoom in here. Yeah, this camera is like backwards, so it's harder to show things. Okay, we have ones, tens, hundreds, thousands, 10,000.
Mm-hmm.
Hundreds, thousands, millions. And so each group of 3 has a name. So you have millions. Okay, right here. Millions, 10 million, 100 millions. Then you get to billions. 10 billions, 100 billions, and then trillions. Okay. Then you have 10 trillions, 100 trillions place, and then you go to quadrillions. Okay. And increasing with powers groups of 3 from there, we have adopted uses of Latin prefixes. Okay. So after the quadrillions, you have sets you have the quintillions place, the sextillions place, septillions, and non-millions, and decillions. And so each of those have like a 10 quintillion, 100 quintillion, then you get to sextillion. So those are how big we get numbers. But for this course, you only go up to like I have a question about like trillion, but so there's more numbers out there that are great. And some of the students that you'll have, when you talk about big numbers with them, they'll come up with things like gazillion and all that. But it's a really fun lesson when you get to do that. Does anybody else know of any other big numbers? Big numbers, huh? Okay. So has anybody ever heard of a Google before? This is how you spell Google. That's how you're supposed to spell it. But the company that we know and love, right? Search engine, they spell it differently for their company name. Okay, but this is also a really big number. And a Google is 10 to the 100 power. That's how big it is. So it has 100 zeros after 10. Okay? So just like a million has 6 zeros, trillion has 10 zeros, and so on, a Google is 10 to the 100. And another fun number, you might have heard before, I don't know, but my favorite movie is Back to the Future, and so the doctor in Back to the Future says that his love is 1 in a Googleplex. So he says that, and so a Googleplex is 10 to the Google power. Okay, that's what a Googleplex is. That's a really big number. And then you have infinity, which they do a symbol like that, like a little sideways 8. Now, infinity is a really big number. It's more of an idea, really. So if you get to a place where the top very limit of numbers. Okay? And infinity is really cool because I'll talk about it in 2020, but more like getting to infinity, what you can do that. And that's what calculus is based on, is how to work with math when you get to infinity. It's very interesting. So those are the names of the numbers that are multiples of 10, but for base 10. But we also have this decimal point where we can do parts of numbers, okay? After the decimal place, we can do parts of numbers, and you can go ahead and thank the French scientists for that one, because they are the ones who invented decimals back in the late 1700s, maybe even a little bit earlier. But decimals are great because you have the structure of the base 10 is maintained, because ones are 1/10 the size of tens, And what is 1/10 the size of a 1? Well, that we call, in our number names, we call it tenth. You guys have seen all this stuff before, so I hope it's not too boring or mundane for you. Just reminding you how to do these things. I'm writing down the more places. Okay, and when you introduce these places in elementary school, you have to be careful because the names are very similar to what they are for the whole number bases. Okay, you have to emphasize or like pronunciate or the th part kind of more heavily at the beginning. So this is a tenth. This is a hundredths place. Oops, tenths place. I put an S at the end there. This is tenths place, hundredths place, thousandths place, and 10,000ths. So there's a hyphen between the 10 and the thousandths if you talk about the 10,000ths place, because both of those numbers describe the place. Remember, these are adjectives. Okay, so you have two words, two adjectives describe one noun. You have to hyphenate them. This is the 100,000ths place. Well, they don't do it up here though, but they only do it for decimals. I don't know. Okay, and so on. And so this, after hundreds, thousandths place, you have the millionths place, which the pattern will continue after that. 10 millionths place, 100 millionths place. But in the homework, they have only one problem that goes down to the millionths place. Okay. So everybody good on base 10 names? Yeah. So that was our first concept. The second concept is about writing numerals given the number name in words. Okay. So so that's this one right here. So I know there's like this whiteboard feature on here, but I can't seem to get it to work on my computer or screen share. So I'm going to go back to Zoom, I think, next week. And so we can do screen share. You can see maybe a little bit clearer. What we have is you've done this before. So I just give you some examples. So we have 3,457. So we're given this whole long word list here, 3,457. We need to write the numeral on it. Okay, so the numeral of that, all of those words. Okay, numerals are the number symbols. Okay, the number is the word, the objects that it can represent, and all that together. But the numeral is actually the number symbol. We do a Hindu Arabic numeral system. And in previous iterations of this course, I've taught like different number systems from like Egypt or Babylonian or other Romans, but we're gonna cut that a little bit and then add some more important stuff later on. Okay, so numerals are just the symbols. So 3,457. So I started out with a pretty easy one. Okay. And then with these words though, we don't need to write, if there's a place that has a 0, we don't need to write the word for it. We skip that, that's a placeholder. So when you're converting for writing numerals from words, you have to kind of interpolate that meaning based off of the numbers, number words they give you. So here's the one, 400, 2,000, 13. Okay, and so what they're going to do in the homework is that they're going to skip places just to test your knowledge. So if we have one that says 400, 2,000, 13, Notice that I did not write any ands in there. Okay. If I put ands in there, then that means decimals, and we'll get to that at concept 3. So we want to write the numeral for this, 402,013. Not and 13, 402,013. Okay. All right, so does anybody have that down? You want to kind of show their screen, show your paper on your screen? Anybody got the number for that one? Okay. Doing a, this is, now careful, this is 400,000, okay? What I'm showing you is that is a teaching technique that you can have your students use. You can have them write their answer on a whiteboard, okay? And little whiteboard tablet thing, and you can have them hold it up, and you can kind of see if they're getting it. So the key words are 402,000, 402,000. Okay? So you want to do, something like this, because it is 402,000. Yeah, don't write ands in here because and is when you start introducing the decimal point. I have to skip all the ands. 402,000. Okay, good, Melissa. And here's the 13 here at the end, but I'd have no hundreds there, so I have to put 0 as placeholder since I didn't mention any. And there's no tens thousands place, no value there because I didn't list it in my numbers. Okay. Let's try another one. I'm going to skip places here just to help test that knowledge. Okay. This one might be a little bit easier. 3,000,006. 3,000,006. Okay, Shelby, good. All right. Okay, good job, Sydney. Okay, so I have like 4 people with their screens up, but there's like 15 people in the class. So maybe Zoom will be better next time to help show. I need to double check to see if you guys are doing what you're supposed to. Okay. So I'm gonna go ahead and move on though, for time's sake. Okay, so we have 3,000,006. Let's try another one. I have a few more. We have 1,700. Okay, that's a little bit better. We've got some more people up. 1,700. Now, what I'm illustrating with this is starting to introduce a kind of more complicated, and good job, Mel. A little bit more complicated setup. What they'll do in the homework. You can name a number based off of the. Okay, good job, everyone. Thank you. You can name the number based off of the place. Wherever 17 is the number name, and if they say 100, that means that's the place that you end with on the number. You write down the number itself, and then you end on that place. So 1,700, I have 17, and then the 7 is ending in the hundreds place. And so that's the number I get. Okay. Good. And so what we're going to do is we're going to do another one of those kinds. Okay. If I have the word number 45 tens, go ahead and try and put that one together. What would you do as numerals? And now you would not probably say 45 tens. Even though sometimes we say 1700s, you probably wouldn't say 45 tens. But it's important because we're going to also get to talking about these in when we get to multiplication and addition. Okay. So if you have 45 tens, how much is it really? And then what would the digits be? and 45 tens. You need to have, okay, so I see what some people are okay, some people aren't. They've got, so we go on to the 5 to end in the tens place. Okay? 45 tens. Okay, some people are putting up 4,500. So make sure that you got 45 and the 5 is ending in the tens place. Okay? So I've written 450, and I note that the 5 is ending in the tens place. So 450 is the same as 45 tens. Good, Melissa, good adjustment there. Now remember, we have the mistakes that we will make, and we want to provide a classroom environment where it's okay to do that. And you can go ahead and make adjustments, because those are where more of your learning opportunities will come. And it's important to encourage your students to do that when you become teachers. Good. So 45 tens. Here's another one. So hopefully everybody's up for this one. This one is like the homework. We have 170 hundreds. $21 tens. Four ones. Okay, so we have lots of number names here. Let's go ahead and add them together once you figure out which one is. You have 170 hundreds. Okay? 170 hundreds, 21 tens, and 4 ones. So if you put all of those together in numbers, you can do them separately and then add them together. Because a number like 125 is 100 plus 20 plus 5. And we'll talk more about that later, about the expanded form. But you're doing 170 hundreds, 21 tens, and 4 ones. So you guys can all see that okay. All right, Marley has hers. Okay. So what? Okay, so everybody's getting different answers. Okay, good. Some people, all right. Some people have given it a good go, which is fine. Okay, let's go ahead and analyze it piece by piece. So we have 170 hundreds. So what I did first is I wrote down 170. Okay, so some people are showing me things. Okay, so let's go ahead and double check those. Now I wrote down 170, and that needs to be in the hundreds place. Now Camilla's done a chip chart, which is good. That's probably helpful. But you have to kind of adjust because of the places. Okay, so that 0, because that's the end of my number for 170, needs to be in the hundreds place. And so what's left for me to write down on this numeral is the tens place and the ones place. Okay. So I wrote down the tens place and the ones place as zeros. So 170 hundreds is actually 17,000. Okay. They're the same. So it's okay to have different values, just like what we did before. What we traditionally do with 1,700, we can also say 1,700. But in our regular English, we interchange those a lot of times. But with something like 170 hundreds, we don't say that very often. So that's why we're going to have to sort it out. So after 170, you need the hundreds place. Then you're going to put in with 21 tens. So with my 21, I need to write 21. Where the number ends, I need to have that be the tens place. Okay. So in order to figure out the rest of this number, I need to put the ones place in. Okay. So 0 is our placeholder. Okay. So 21 tens is actually 210. And then there's 4 ones. Now 4 ones is just 4. Okay. So I'm going to add these up. And my number is going to be all of those added together. Now, it just so happens that I can add this up easily because the 210 goes with those 3 zeros there, and then the 4 goes with that 0 there. So we have all the digits have a place now. Sorry, all the places have a digit now. And if you got 17,214, then you're good. All right, so that's the trickiest one on this concept with the homework. They have one, the book throws one of those in there, which is kind of silly in my opinion, but they do that sometimes.
I have a
Hey.
question. Was
Yeah.
it 170 hundreds?
Yes.
Okay. So it was 170,214, or?
Yeah. So we have 1700 for 170 hundreds. Okay, because that 0 right there needs to be in the end number ends with the place that we're talking about.
Oh, okay. So I just have an extra 0 in here then?
Yes, you do.
Okay.
And I like how we do in this country, we do commas for every 3 sets of 3 places. So that's really helpful. Okay, concept 3 is decimals. Wait, no, that's example 2 for concept 2. Okay. We're going to do the same thing with some decimals now. Okay. Decimal words. We're going to give you the words and you have to write the decimal for it. Okay. So here's the words for a decimal. So I'm going to go quickly through this because we're running out of time. Okay. 29 and 4/10. Okay. So as you take notes, just write the number for it. 29 and 4/10. Now the and means decimal. Okay. In the book, there is one example where they mistakenly put and in for a regular number, but to be consistent, we need to keep just and as a decimal. Okay. As you introduce decimals, whenever you do that in your classes, whatever grade that is, I think it's like 4th grade, 3rd grade, you want to talk about this as not just as 29.4. Okay, you want to kind of say the whole number, 29 and 4/10, because it will help when you convert decimals to fractions. Saying 29 and 4/10 will help you when you talk about fractions. So let's get in the habit of saying 29 and 4/10. Now, I hope I can remember that because I'm lazy too and I say 29.4 sometimes. But especially when you're introducing the concept to elementary students, you need to use like the full formal way. Okay, here's one. Another one to practice, 32 hundredths. So these are kind of introducing it. I'm going to go ahead and just put the answer down. Okay, 32 hundredths. Now, when you see this printed in text, a lot of times textbooks write a 0 in front, just so that you know that it's a decimal. Some people can get lost on the decimal if it's not big enough. So that's why a lot of times in textbooks, they'll do a 0.32 to say 32 hundredths instead of just 0.32. Okay, so for our purposes, this 0 doesn't matter because we know that it's only going to be 32 hundredths. Just a little note there in case you ever wondered that. Okay. Now, just a little note before we go on the next one. We have 32 hundredths. The naming of this decimal, you have the 32 as the whole name, as the first part of the name. Okay. Whatever is the last place that the 32 ends is the name of the decimal. Okay. So the 2 is in the hundredths place, and so that's why we call it 32 hundredths. Now with that in mind, we want to do 26 10,000ths. 26 10,000ths. So we want to write that as a number. Okay, there will be a 26 in there, but where it is and how many zeros you put in front of it depends on the places. Okay. So it's kind of like what we've been doing before. I have wrote down my 26, but I need the 6 to be in the 10,000ths place. So you got to count backwards to go for thousandths, then hundredths, okay? Hundredths, and then tenths, and then decimal. Okay. So to know where to put the decimal point and how many zeros to put on it, you'll have to count backwards. Okay, so 6 needs to end with the 10,000ths place, and you need to see where the thousandths are, then the hundredths, and then the tenths, and then you put your 0. Okay, everybody got that? Let's do another one. We're going to combine things that we did before. Okay. So here's the big one. I'll hold it up here for a while and you guys work on it and show me your answer. We're going to do the numeral form of 6,002 and 483 millionths. Okay. So you're going to have a part of a bigger number, then a decimal point, and then a little bit of a number. Remember the 483 you write down, and you make sure that the 3 ends in the millionths place. And then you can put the zeros before it to get up to the tenths, and then the ones, and so on. So 6,002 and, which means decimal, 483 millionths. Okay, so, all right, so you have Sydney's holding hers up, and I think you need 400 in there, and then you should be good. You need 483 millionths. So replace one of the zeros with the 4. Excellent. To Marley. Okay, good. Good job, Marley. And let's see, Sydney. Good. All right, Shelby. Okay, good. You got 2 too many zeros there because you need to get to the million. You want the number to end on the millionths instead of start on the millionths. Okay. Okay. Let's see, Melissa. You need 483 together. Okay. So 483 needs to be together, and it needs to end on the millionths place. Let's see, Tony. Good, Tony. Great. Okay. So for time's sake, again, I forgot that we're hurrying here. So you should have 6,002. And it's interesting with decimals, just so if you've seen numbers in other countries. Oh, sorry, Melissa, you had something up. Okay, so just check this one out. So in other countries, they will swap the decimal and the comma. So if you've seen other countries like in France or South America, they will use a comma for a decimal point, and they will use a period for the comma. Okay, so it's interesting. So you might see some money or whatever in currency in other countries written with commas, and that means the decimal. But here we put our decimal point for between the 1 and the tenths place, and this is the tenths, hundredths. I'm going to go to this one. 6002 is easy for you guys, but this one was trickier. So we have the tenths right here, hundredths, thousandths, 10,000ths, 100,000ths, and millionths. Okay, so there should be 3 zeros and then 483 because I did 483 as a number, and then that's the value of it is the 3 is a millionths. Okay. Now knowing that, it will make concept number 3 go a little bit quicker. Concept 3 is the opposite, where I'm going to give you the number and you write out the whole number words. I give you the numeral, you write out the number words. Okay, so we have about 4 minutes, and I'll just do a couple of each of these. So we did all of the things here. Okay. So here's our first one. You have to write the number words, okay, for that numeral.
Can you show the number again? Sorry.
Oh yeah, I was fast on that one. Okay. Now notice that here's the number and the numeral words. 57,005. Yeah, I want to reserve my word and. Some people put 57,005, but I want to reserve my and for decimal points. So it's sufficient to write 57,005. Notice that 57 is going to be hyphenated because any number that's between 21 and 99, except for multiples of 10, are all hyphenated. So I forgot to mention that part, but these are things you guys know, maybe you don't remember, or we're just trying to get it back in the forefront of your mind. So hopefully this is not too tedious for you. Okay, here's one. How much is this number? I'll hold it still here. You can see how many zeros there are. So you want to write the number words for that numeral. Okay. All right, so what do you guys got? Oops, hold it. Yeah, so Lindsay's counting still. Hold it close, Sydney. Okay, there's a little more than a million there. Let's see, Tony. He's got, okay, good. Tony's good.
Mine says trillion.
Oh, it did? I thought it said million.
Yeah.
Oh, the TRI looks like an M. It's amazing. Okay, I got you. Good job, Sydney. From my camera, that's just the way it looks. Okay, 66 trillion. Okay, for everybody who's writing that. Yep. So we got like 1 more minute. Number 66 is going to be hyphenated. Let's go with decimals now. Try to hold this up strategically. Decimals. All right, it's 0.017. Okay, now you name the number 17 is the only real digits there. You write the place by the where the 17 ends. So we have our tens, hundreds, thousandths. So that's why it's 17 thousandths. Okay. Let's go ahead and do a trickier one. Okay. What I have written down here is 8 zeros and a 4. So 8 zeros here, and then a 4. How much is that? Okay, Shelby, close. You got one more place to go over. There's 9 total digits, and 10 to the 9th power is actually a billion, so that might help. Okay, Marley has, I can't read hers very well. Yeah, you got, maybe I'm, okay, people are getting the same as together. Let me see here. Let me go ahead and map out the places. One, tens, hundreds, thousands, millions, 10 millions, 100 millions. Well, I'm getting a lot more than tens, hundreds, thousands, millions. No, 10,000s. Okay, I'm getting mixed up with my 10,000s. 100,000s. Millions. Here we go. Okay, yeah, so I was good. Now, I've labeled all of the places here. Go back up to good frame here. So we have tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and billions. So this should be 4 billionths. Okay, so that's actually, we're out of time. And hopefully that was a good introduction to our lesson. And so, any questions before we take off?
Professor Broderick, is it possible to get emailed the notes that you wrote out today just to reflect on for homework? Well, I did take notes, but just.
Yeah, no, I did record this. But,
oh, great.
So I'll post the recording on Canvas, on YouTube, but there'll be a Canvas link. So look for the link in Canvas. I do have my lesson plan notes too, and the things I wrote down just now. But the things I wrote down just now are kind of crazy, random places. But let me see if I can scan these notes and post them too. So maybe that will help. Yeah.
Okay. If nobody else needs them, I was just asking. I don't want you to do extra work.
I'll just see how easy it is. And
so that would help.
If it's easy, then I'll post them.
Okay.
All right. If you guys have questions, please send me email. And it's great to have you guys today and see you. And happy Friday. See you again.
Happy Friday.
Mm-hmm. Yep.
Have a good weekend, guys.
Bye.